Hi everyone. Today we're going to study shifting property of Laplace transforms. In this video, we're going to take the Laplace transform of the function e raised to at multiplied by f of t, or the Laplace transform of the function e raised to negative at times f of t. We know that Laplace transform of the function f of t is equal to the function capital F with respect to s. Then let us discuss Laplace transform of this function e raised to at multiplied by f of t. First step is we're going to evaluate Laplace transform of the function f of t. The answer is a function capital F of s. From here, we're going to do the shifting. It means from s, we will shift into s minus a, which means we're going to evaluate the function with respect to s minus a. Take note that the a here is the coefficient of t in the exponent of this exponential. What about the Laplace transform of the function e raised to negative at times f of t? First step, we evaluate Laplace transform of this function f of t. The result is a function capital F with respect to s. From here, we will do the shifting. From s, we will shift into s plus a. Or we say that we evaluate the function with respect to s plus a. Again, the a here is the coefficient of this negative t in the exponent of e. Example 1. Evaluate Laplace transform of e raised to negative t times sine 3t. This problem is of the form of L of the e raised to negative at f of t. When we collect the given based on the problem, we can see that the f of t is equal to the sine 3t and the a is equal to 1. Remember, this 1 is the coefficient of the negative t. In the final answer, we're going to evaluate the function capital F with respect to s plus a. Now for the step 1. Let us evaluate Laplace transform of the function f of t. Our f of t here is the sine 3t. Then the Laplace transform will be 3 over s squared plus 9, which means this is our function capital F of s. So for step 2, we will evaluate the function with respect to s plus a. Remember, in the beginning, our a is 1. So the function will be evaluated with respect to s plus 1. This is our f of s, which means the function of s plus 1 will be like this. 3 over the square of s plus 1, then plus 9. We expand the square of this binomial, we will have like this. And we simplify further, it means we combine this plus 1 and the plus 9. So final answer is 3 all over s squared plus 2s plus 10. Example 2. Evaluate Laplace transform of the function t squared times e raised to 5t. The problem is of this form. Then let us collect the given. The f of t is equal to this t squared, and the a is the 5. In the final answer, it will be the function capital F with respect to s minus a. Then step 1, evaluate the Laplace transform of f of t. The f of t is t squared, so we have like this. Then we evaluate the corresponding Laplace transform. It will be 2 factorial all over s raised to 2 plus 1. We evaluate this fraction. In the numerator, we have 2 times 1. It becomes 2 over s cubed in the denominator. This is the value of our capital F of s function. Then the step 2, we evaluate the capital F with respect to s minus a. In the beginning, the value of a is 5. So we have f of s minus 5. The f of s function is here, so the f of s minus 5 will be like this. This is the final answer. Example number 3, find the Laplace transform of e raised to 7t times sine square of t. The form is L of e raised to 80 times f of t. Then we collect the corresponding values in the given, which means f of t is equal to the sine square of t, and the a is equal to 7. In the final answer, we will have the function capital F with respect to s minus a. We go now to step 1. Let us evaluate Laplace transform of f of t. This is our f of t. So we have this L of sine square of t. We don't have a direct formula for Laplace transform for the sine square of t. Take note that we have an identity that says the sine square of t is equal to 1 minus cosine 2t all over 2. Let us replace this value for the f of t. So we have like this. Let us simplify further by putting the constant 2, or I mean 1/2, in front of the Laplace transform. So we have this 1/2 times Laplace transform of the quantity 1 minus cosine 2t. From here, let us take the Laplace transform of respective terms, which means Laplace transform of 1 minus Laplace transform of cosine 2t. Let us evaluate the corresponding Laplace transforms. For Laplace transform of 1, that will be 1 over s, minus Laplace transform of cosine 2t is s over s squared plus 4. And then we multiply this 1/2 to all the terms inside the grouping symbol. So we have this 1 over 2s minus s all over 2 times the quantity s squared plus 4. This is now our function capital F of s. We proceed to step 2, that is to evaluate the function capital F with respect to s minus a. The a is given here as 7. So we have f of s minus 7. So f of s is here, therefore the f of s minus 7 will be like this. This is now the final answer. Example 4, evaluate Laplace transform of e raised to 4t times cosine h of 5t. This problem is of this form, then we collect the corresponding values. The f of t is equal to the cosine h of 5t, and the a is equal to 4. In the final answer, it must be a function capital F with respect to s minus a. Then we go to step 1. Evaluate Laplace transform of f of t. The f of t is here, the cosine h of 5t. Then we use the formula for the Laplace transform of cosine h 5t. It becomes s all over s squared minus 5 squared. We simplify this 5 squared into 25. This is now our function f of s. Then for step 2, we evaluate the function with respect to s minus a. We took the value of a here as 4, so we substitute it here. So we evaluate the f of s minus 4. The function now will be s minus 4 all over the square of s minus 4, then minus 25. Let us expand the square of this binomial. We will have like this. Then we combine the positive 16 and the negative 25. So the final answer is s minus 4 all over s squared minus 8s minus 9. Example 5. Evaluate Laplace transform of t times e raised to negative t times sine 2t. The problem here is of this form. Then we collect the corresponding values. The f of t is equal to t times sine 2t, and the a is equal to 1. The final answer must be a function of f with respect to s plus a. Then we go to step 1. Let's evaluate Laplace transform of f of t, and this is our function. We substitute it here. From our previous video, we have the property of Laplace transform, and this Laplace transform of t times sine 2t will be equal to negative of the derivative of Laplace transform of sine 2t. Then we evaluate this Laplace transform of sine 2t as 2 all over s squared plus 4. Then we take the derivative of this fraction. We can use our quotient rule of derivative. So it becomes like this. We can simplify the numerator and it becomes negative 4s. Simplifying further for this negative sign outside and the negative 4s, the numerator becomes positive 4s all over the square of the quantity s squared plus 4. This is now the function of f of s. For step 2, we evaluate the function with respect to s plus a. The a value is taken as 1, so we have this f of s plus 1. Our f of s is here. When we evaluate, it becomes like this. 4 times the quantity s plus 1 all over the s plus 1 quantity is squared plus 4. And the whole polynomial is squared. Let us simplify the square of s plus 1 into like this, and then we combine the constant 1 and the 4. So we simplified it like this. Final answer, 4 times the quantity s plus 1 all over the square of the trinomial s squared plus 2s plus 5. I hope you learned something from this video. See you again next time.